Hello there! This is an Algebra 1 video. It is Chapter 8, Section 2. Today we'll be learning about multiplying a polynomial by a monomial. Trust me, it'll get more complicated as time goes on. But for now, it's easy peasy, Japanesey. Alright, so basically what we want to do here is be really careful that we distribute. You want to take negative 3x squared and multiply it by each term in the parentheses. So negative 3x squared times 7x squared, and then minus 3x squared times negative x, and negative 3x squared times 4. So we're taking the negative 3x squared and multiplying it by each term in the parentheses. You'll remember from the previous lesson that when you're multiplying the same base, you add the exponents. So x squared and x squared, you're going to add the two exponents there, and you're going to end up with x to the fourth. And of course, negative 3 times 7 is negative 21. So you get negative 21x to the fourth. Here you're going to have negative times negative is a positive. And then you have 3. And then again, x squared times x to the 1. You add the exponents, and 2 plus 1 is 3. So you get x cubed. And then lastly, negative 3 times 4 is negative 12. And since there is no other variable over here, you just have negative 12x squared. It is already in standard form because x to the fourth is the leading degree there. So there's your answer. Negative 21x to the fourth plus 3x cubed minus 12x squared. So now we're going to ask you to find each of these products in much the same way before we move on to the next example. Alrighty then, example 2 says to simplify. Pretty much the exact same thing, only now we have two of them. Alright, but that's not a big deal for us. We're cool, we're going to do it anyway. So we're going to take 2p and multiply it by negative 4p squared. And because 2p is positive, we're going to go plus 2p times 5p. So again, we're taking the 2p times both terms that are in the parentheses. But at the same time, we also want to do the same for the negative 5. We want negative 5 times the 2p squared, and also negative 5 times the 20. Okay? So, here we have 2 times negative 4 is negative 8. And p to the 1 power times p squared, you're going to add those exponents. So you're going to get 1 plus 2 is 3, so we're going to get p cubed. And then we're going to have plus 2 times 5 is 10. And p times p is 1 and 1, so we're going to get p squared. And then over here we're going to have negative 5 times 2 is negative 10. P squared, because there's no other variable there. And then lastly, negative 5 times 20 is 100, negative 100. So here's your answer. Actually not quite, because I didn't simplify it. Shame on me. Okay, so now that I've done that, I see that I've got like terms here in the middle. I got positive 10p squared and negative 10p squared. So I need to combine those. So positive 10 and negative 10 actually equals 0. So they're going to cancel. And all I'm going to be left with is negative 8p cubed minus 100. All right, negative 8p cubed minus 100 is our final answer. And now you can try these two examples in much the same way. And we will go to example 3. Oh, word problem, our favorite. Okay, the theme for a school dance is solid gold. It's kind of lame, but forgive them, for they know not what they do. For one decoration, Kana, I don't know what her name is, some girl, is covering a trapezoid-shaped piece of poster board with metallic gold paper because she wants it to look like a bar of gold. That is how creative they are. If the height of the poster board, which is right here, the height of the poster board is 18, so I'll fill that in. How much metallic paper will she need in square inches? She being Kana, whatever her name is. Okay, so first thing, I don't know if you know this already or if you've forgotten it, you probably want to know the area of a trapezoid. So the area of a trapezoid is 1/2 base 1 plus base 2 times the height. That's just from prior knowledge if you didn't already know that, but that's the formula for the area of a trapezoid. So base 1 and base 2 we know is h plus 1 and 2h plus 4. And the height we know is 18. So all we really have to do here is plug in the information. So we're going to get 1/2 base 1 is h plus 1, and base 2 is 2h plus 4. And then we're going to times that by h. Okay, so you have a 1/2 in front and an h in the back, but probably the easiest way to do this is to take and simplify what's inside these parentheses first. So 2h and 1h is going to give us 3 h's, and 1 plus 4 is going to give us 5. And then we're going to take and multiply, because we have an h out here, right? So we have to distribute this h to everything inside. So h times 3h is going to give you 3h squared, and h times 5 is going to give you 5h. But then, of course, you still have this 1/2 out here as well. And the 1/2 also needs to get distributed. And so when you have 1/2 times 3, you're going to get 3 halves. So 3 halves h squared. And then 1/2 times 5 is going to give you 5 halves h. And this is now in the right order because you have the h squared first. And then the last thing we want to do is actually plug in the h. And you know, we could have made this a lot easier if I would have plugged in the 18 a long time ago. We could have plugged in 18 for h as well. I totally forgot about that part. So when you plug in the h, it makes it easier because then you don't have all these crazy fractions. But we already did it, so let's just go ahead and plug it in now. So we're going to go 3 halves, and h is 18, plus 5 halves times 18. So 18 squared is going to be 324. So 3 halves times 324. And then we have 5 halves times 18. So 324 times 3 halves is 486. And 18 times 5 halves is 45. And if we combine 45 and 486, we get a whopping 531. So the question was, how much metallic paper will she need in square inches? 531 square inches of fabric will be needed for that. All right, so now you are going to go ahead and do this do-it-yourself question, very similar problem. And then we're going to go to our last example, which is pretty much the same exact thing, only now we have this issue with having variables on both sides of the equal sign. Now this is really important because especially for this Algebra 1 class, I've seen this a lot in the past, I've yelled at you about it already many times, is that when you have variables on the same side of the equal sign, you do not do the opposite. Do not, do not, do not. But when you have them on both sides, that's when the opposite needs to happen, okay? So I'm going to show you how to do that here. First and foremost, we're going to start with our distribution property. So we're going to get 2a times 5a plus 2a times negative 2 for the 2a times 5a, 2a times negative 2. Then we're going to have 3a times 2a plus 3a times 6. That's distributing our 3a. And then, of course, we have plus 8. On the other side, on the right-hand side of the equal sign, we have a times 4a plus a times 1. And then we have 2a times 6a plus 2a times negative 4. And then plus 50. So I had to kind of come down here because I didn't have enough space to keep going all the way over here, right? But right now, when I deal with the left-hand side, all of these terms are going to have the same, they're going to be on the same side of the equal sign. So 2a times 5 is going to give me 10a squared. 2a times negative 2 is going to give me negative 4a. And then here we're going to get 3 times 2 is 6a squared. And then 3a times 6 is going to be plus 18a, and then plus 18. Okay, so what I'm saying here is that when I look at the 10a squared and the 6a squared, they're on the same side of the equal sign. So I'm not going to go 10 minus 6 or 6 minus 10. I'm just going to leave them as they are and combine them together. 10, positive 10, positive 6 is positive 16a squared. Same is true for the negative 4a and the positive 18a. They're on the same side of the equal sign, so I'm not going to reverse any symbols. I'm just going to combine them. What is 18 and negative 4? Positive 14a. And then lastly, we have our plus 18. So that's what happened on the left-hand side. Okay, we get 16a squared plus 14a plus 18. Now, on the right, we have 4a squared, because a times 4a is 4a squared. Then a times 1 is just a. 2a times 6a is going to give you 12a squared. And then 2 times negative 4 is going to give you negative 8a, and then plus 50. And again, on the right-hand side, I'm going to combine the 4a squared and the 12a squared. So not going to do anything weird with like negative 4 or negative 12. I'm just going to combine positive 12 and positive 4. It's going to give me 16a squared. Then I'm going to take the positive a and the negative 8a, and 1 minus 8 is negative 7a. And then lastly, plus 50. Okay? So now, at this point, now you're trying to combine like terms and you want to move them from one side of the equal sign to the other. This is now when you start doing the whole negative thing or opposite, okay? Now, because this is positive 16 and I want to move it to this side to join with these 16, now I have to subtract. In other words, do the opposite of positive 16, which is negative 16, because I'm moving it to the other side. When you're not moving it to the other side, you just combine them as they are. So in this case, 16a squared minus 16a is going to cancel on both sides. So we got lucky with that, and you're going to end up with 14a plus 18 equals negative 7a plus 50. And again, to try to combine the a's on the same side, I am going to now add these 7a's over here because I'm moving it from one side to the other. So they're going to cancel on the right, but they don't cancel on the left. 14 plus 7 is now 21. A plus 18 equals 50. And to move the 18 to the other side, I will now subtract it. So I get 21a equals 50 minus 18, which is 32, and then lastly we will divide by 21. 32 divided by 21, and you're going to get that fraction, which is approximately 1.523. Alrighty? So just be careful when you're trying to move things from one side to the other and when you're just combining on the same side of the equal sign. But that is how you get that answer. And now you can do this last example, and once you have completed that, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.